In this video, I wanted to conclude our observation of functions from the polygraph activity that we had done earlier. And when I looked at these three functions, I thought, oh, these three functions are kind of special functions that we use all the time. And then I realized that one is not, but that's okay. So we have three functions that we use a lot. One is an absolute value that kind of looks like this. One is a quadratic that looks like this, and one is a cubic that looks like this. So this is just basically looking at functions that do things at different ends. We're still going to look at domain and range. So like we have before, we're going to see that our domain is how wide. So we're going to write our ruler from left to right. And this here is going to be our domain. And so I want to know how far this function goes to the left and how far this function goes to the right. So what you have to do is you have to imagine that this function extends. So I'm just going to draw the function off of the graph. It keeps going up that way forever. And on this side, it keeps going up that way forever. Okay? So we can see that this function continues getting wider and wider. It's narrow here and it gets wider and wider here. So if I want to know what the value of my x is way out here, I would have to look down at, take a peek down at my x-axis again and say, what is the value of x way out there? Well, because it's continuing forever to the left, I'm going to say that's negative infinity. So as I'm holding my ruler stick and I'm going along the function, I'm touching the function and the x-axis at the same time, and it keeps going forever in the other direction, which is positive infinity. So this means my function is, as I call it, forever wide. So it's all values of x. Any input you want will be okay to use in this function. So for domain, I'm going to say it's all real numbers. So any number I want, I can put into this function and it will draw some part of this particular function. So in set builder notation, I'm going to write the set of x such that, now this is going to look funny, x, this means is the set, okay, that's a Greek letter, is the set of all real numbers, okay? So it has, R has kind of like a funny backbone. For interval notation, it starts at negative infinity and goes all the way to positive infinity. So that would be negative infinity to positive infinity. So that's always going to be true for functions that go up on both sides like that forever. Okay, there's going to be no exception to that. So now let's do range. Range is a little trickier. So again, with range, I'm dealing with my y-axis. I'm just going to move it off to the side of the graph. So I'm always thinking bottom to top. So my bottom is where the lowest point of my function is, which is there, which would be this value of y right here. So that value of y right there is negative 1, 2, 3, 4. So that's where y is negative 4. And if I hold my stick on the y-axis, it's always touching the function as I go up forever. So it's starting here at negative 4, and I'm going up forever. So when I get to the top, I'll be at positive infinity. So if we're going to do set builder notation, this is where y gets bigger. So I'm going to say the set of y such that y is bigger than, you could say greater than, or equal to -4. If I'm going to do it in interval notation, I start at -4, it includes it, and I go all the way to positive infinity. So notice that this graph right below here, this is a quadratic. So let's just go ahead and give it the name quadratic. I'm just going to write it right here. It's a quadratic. And so just notice that the ends are kind of similar to the ends here. I'm going to put an arrow. So what you have to realize with this function is that this is going up, but it's also getting wider. And same with this. It's going up, but it's also getting wider. So if I wanted to figure out, well, where does it start? Does it start here? No, because notice that this is going up and getting wider. So just like this V-type function, this function goes all the way to the left as far as possible. So again, this one here, it's going from -infinity to positive infinity, because as it's going up, it's getting wider. So these two functions just happen to have the same domain. So here we're going to say that set builder is a value of x such that x is the set of all real numbers. And in interval notation, all real numbers means from -infinity to positive infinity. So now when we look at range, we can see they're similar. This here has a floor. The floor is right here. I'm just going to write it right here. And that's where we have y is -1, -2, -3. So I'm going to do my y-axis off here on the side. So I'm starting at -3, and it's going all the way up. So it goes up forever to positive infinity. So that means then that my range is, well, the set of y such that y is getting bigger as it goes up, greater than or equal to -3. And that would mean in interval notation, my y starts at -3 and goes up forever. So then our last one here is kind of tricky. This here is actually a cubic function. So let's just write it's a cubic. Okay, and remember that this goes up forever and down forever. So it's hard to see because it looks kind of skinny, but I'm going to do something a little different. I'm just going to look end to end. So if we look end to end on this function, see if I can get it a better view. If I just go end to end, I'm just going to use an orange thing. So I'm just looking at it as though it were linear. You can see that it starts getting wider at the ends. It's getting wider at the ends, and it keeps getting wider as you draw it. So once again, that means that my domain is as far left and as far right as you can go. So that's going to be -infinity to positive infinity. And my range is going to be as far tall as you can go. So that's then going to be -infinity to positive infinity. So here, both the domain and the range are the same. So here, my domain is a set of x such that x is a set of all real numbers. Interval notation would be from negative infinity to positive infinity. My range is y, such that y is a set of all real numbers, and an interval notation is still going to be from negative infinity all the way to infinity.